We are a bit early today, but I just wanted to come in to check if anyone has any question before we start. So feel free to drop it in the chat, and then I will check the chat to see if there is anything I can help with.
Hi, I actually had a question about the lab.
Yeah, go ahead.
So my question was, for the one part where you want us to change the path variable, my computer just brings up like a whole bunch of different I click on the path and instead of hitting like new and you're only getting like one like sort of thing that you see on, I don't know how to describe it. Basically, when you clicked path, it showed you like one thing that you can change. For me, it's showing like 8 different things. So I was wondering, do I just hit like new and add another place there, or?
So I'm just trying to relate this to which part of the lab. I guess you are talking about the part in the lab that asks you to change the default path when importing or creating the Eclipse project to point to the folder where you cloned your Git repository. Am I correct?
Yeah, let me just get there 1 second.
Okay, so given that this is a bit of an involved thing, it might be better to share screen. Did you try to come to any of the office hours to share that with? Because usually what we do in the office hours in the lab is either me or the TAs will be there, and you can share a screen, show exactly when and how the problem occurs, and then it would be much faster to help with that, right?
Okay,
So I'm just saying, yeah, go ahead.
when's the next office hour then?
So every day we have office hours from 10:30 to 2:30, and today I have my office hours after the lecture until 3. So lecture 0 PDF is the one that has all the information to make sure you can check that. Okay, there is a yeah, thank you. So there is a question in the chat, Michael, saying what are header files? Okay, that's a question that it's better addressed during lecture, so that's good. So basically, you can write everything in C files. You can have a single file. The whole project can be in a single file, but that's not a good programming practice and not a professional way of writing programs. Usually for big projects, and this is why we construct the labs the way they are to be modular, is we separate definitions from implementation. So header files are usually the files that contain, for example, the prototype of functions, right? And then the C files or the source files themselves, they will contain the actual implementation of the function. By doing that, you separate the definition or declaration or prototyping of a function from the actual implementation of the function. Think of why might this be useful. For example, if you wrote a very big project and you give this to a user or to me or to a collaborator to work on, I don't need to look into your detailed implementation to be able to use your functions. I just look into the header file, see what functions you have, what parameters they take as an input, what they return as an output. Hopefully you have also some kind of useful comments there, and that's enough. So you can think of header files also as a useful mean to provide an interface to the functions you have in your implementation. Take, for example, Lab 0. In Lab 0, we put the header file of the function, which has add function. This is very simple, so it doesn't make a big difference. But think of if you have 100 functions, then you only have the prototype, which is the first line of a function. And when we talk about functions next lecture, we will come into this in details. And I guess the question will also become clearer. But basically what we have in Lab 0 is in the header file, we only have the declaration or prototyping of the function. This tells you this is an add function that takes two input parameters, return an int. That's it, right? The actual implementation is in the C file. Good. So how can you submit lab on GitHub? That's a good question. And in fact, I assume this might be clear, but let's re-emphasize this. One beautiful thing about the environment we're using right now in GitHub, by pushing to your repository, you have already submitted your lab, right? So you don't need to take about further steps to upload the code into Avenue or anything. Then the question comes, if you pushed and you have a problem, what you can do, you can simply just fix your problem, do an add commit, and then push again, and then we have another commit in your repository. So we only, as I said, last 2 lectures, we only mark the last commit in your repository. So if it passes, great. If you have previous 100 commits that are all failing, don't worry. Like if the last one is passing, that's perfect. Have you posted slides for this lecture? This is from the previous lecture, because I like previous lecture, I had the slides for the previous lecture and this one together. So we are continue from the previous lecture. We don't need other slides. Are we going to cover material we need for the lab in lecture? I'm not sure what you really mean by material. So if you mean theoretical information, this is what we do usually. I guess this is your question, Laura. So we usually cover all the theoretical, and even we do some practical examples in lectures. But also in tutorials, I touch more on some specific details with regard to each lab, right? I'm confused what questions are asking. Oh, if because the lecture didn't start yet, so I'm just taking whatever questions you have, because effectively lecture time didn't start yet. Do we know our mark before? So the final mark of the lab, you don't know until you submit, and then we do the grading, because in addition to the tests you have in your starter code, we also have some other tests in our site that we don't expose to you, just to make sure that your test covers all possible corner cases. But you can have a sense of whether you, for example, if you don't pass the basic tests you have and the ones you add, that means you have a problem you need to fix. What is the exact due time? It's the 11:59 EST time. So last minute in the day, like Hamilton time. Sorry, I'm in the lab question. I'm confused. So yeah, I guess I see. Now I see your point. So I guess Laura, you're saying what questions they are asking. I'm just taking random questions, given that we still have a couple of minutes to start. Yes, once you push and you find that you pass, that's perfect. That's it. If you want to double check, you can look into your GitHub account for Dean. I guess this is your question. So you can just go. The question is, how do I confirm that everything is handled correctly after pushing? You can simply go to your GitHub webpage, look into your code, check that all changes are there. And in fact, also in using GitHub Classroom, you have either this like green check mark that everything passed, or you have this like red cross mark that tells you there is something that that is not passed. Yes, I have office hours until 3. That's correct. Lecture slides, Arjun. Lecture slides for today are from last lecture, so you already have the slides. Karina, are there going to be tests that input the wrong type, like string instead of integer? And no, for now you don't need to care about that. That's an excellent question, in fact. So for now you only need to care about the user is inputting the correct types. So don't do any additional thing to guard that. When is the midterm? This week I'm going to post the midterm date on Navian. Right now I just don't recall it out of my head, but I will post it this week. Okay, so I guess it's 12:30, so let's start to leverage the time. Okay, let me share. Okay, so last time we stopped at this example. So let me just make sure I see the slides here. So, okay, so what we want to do, we want to read 15 floating point numbers. So as you will see, and this is something that is important to get through the lectures, every lecture is building on top of the previous ones, right? So what I advise you to do is, after, maybe one way to study this course is after you finish the lecture, what you can do is you can try to do the examples yourself, right? By doing that, and in addition to what you do for the lab, you will get the concepts you have your hands-on programming, and then when you come to the lecture, you will be prepared. So every time I'm assuming we are building on top of what we had before, right? So previously we saw how to read something from the input screen, output something to the screen, do some conditions, looping. So we are building on top of that. So we want to read 15 floating point numbers from the user, and we want to bring them in a reverse order. And this reverse order thing is what is new here, right? That would require some attention. Previously, in all the examples we had, you didn't need to store the values somewhere, right? You are just reading them one by one, so you don't have a memory in your program, basically. You only have a single variable that each time you modify by reading something from the screen, correct? Now it's a little bit different because you need to bring things in reverse order. So you want a bit of a memory or a data structure, what we call a data structure, that stores these values such that you can bring them in the reverse order or do some operation on them. At the end of the last lecture, some of you kind of suggested some kind of advanced data structures like queues and stacks, but we yet don't cover this in this early stage of the course. So the easiest thing you can do, the easiest type of memory that can store things of the same type is an array, right? So what we can do is we have to store all of them, and we can use arrays for that. So one thing I want you to understand, let me do that. So one thing I want you to understand is really what are arrays. You guys use arrays in Python, and for some of you that are familiar with programming, you might be familiar with arrays. But there is a difference between someone who is writing a program by using a tool or someone who understands really what is going on in hardware, in compiler, what are the operations that are done. And understanding these differences is what makes a good professional programmer from someone else, right? So what is an array really? It's a data structure, it's a very simple one. And it has its own advantages and disadvantages. One of the, and in fact, the characteristic that leads to both the advantages and disadvantages is what I'm going to say right now. What differentiates arrays from any other data structure is that these are contiguous places in memory. So what I mean, assume and forget about right now about the syntax, right? So I'm just defining an array of ints that has, I don't know, 50 elements, right? By just defining the array, what you do is in the memory, you remember we said for ints, you just reserve a storage in the memory for the int variable, right? Which is 4 bytes. By defining an array of ints, you reserve a place in the memory for the whole thing, for all the array, which is like 50 elements right now. So these are 50 elements. Each one of them is an int. So each one of them is taking 32 bits. And you have 50 of those. The big difference between arrays and other things is that all these variables, all the elements of the array are contiguous in memory. So what they mean is, for example, if this is at address 0 and memory is byte addressable, and you'll see this in the digital design course. So the first element as 0, each one is like 4 bytes. This will be at 4, 8, 12, 16, etc. Right? So they have to be contiguous in memory. Other data structures are not like that. And this is a big difference between arrays and others. So why it matters, right? Because if you access elements that are contiguous in memory, you access them faster. Without going into details, because you have caches, you have locality in your hardware that just once it recognizes you're accessing something in a sequential manner, they just brought it closer to the processor and they are getting processed faster, right? So usually the access time of the array is very fast, right? And this is a big advantage of an array compared to any other data structure, right? But what is the disadvantage of that? The disadvantage is the array has a maximum size that you cannot go beyond. The reason is because all these places are contiguous in memory. If your memory doesn't have sufficient space that is contiguous to hold all the elements, you will not be able to define your array. As we will see later in the course, once we do dynamic memory allocation, your memory can be fragmented. So what I mean is, assume Your current memory in your laptop is like that. You have, this is a free space, this is not free, this is free, and this is not free, right? So, and assume this only takes, let's say, 40 elements of int, right? And this again takes only 40, 40, 40. By this shape of memory, you will not be able, in fact, to define these 50 elements of the array, right? Because there is no free contiguous space that can accommodate 50 integers, right? So you cannot define the array like this. Your compiler will complain. In fact, this is a very naive example. Most memories will have much more than that, right? The problem will arise when you have megabytes of elements. But just to clarify the problem for you, right? Good. So by doing that, you will not be able to define this array. So the characteristic of the array that led to the advantage that it has a fast access time, it's also the same characteristic that leads to the limitations of the array, which is sometimes your memory will not be able to allocate the 50 elements, even if in total, as you can see, you have a total of 160 free spaces for ints, right? You only need 50, but you don't have contiguous ones, right? This is one limitation of the array. The other limitation is because it's contiguous, so you don't have the address of all the elements. You only need the address of the first element, and everything is sequential. So to search an element in an array, you have to go through the whole array in worst case. You start from the beginning, and then you search the first one. If it's not the one you are looking for, you go to the second one, third one, fourth one, until the end. So searching an array, in worst case, it takes, you have to go through the whole array. And this is another limitation of an array, right? Again, because of its contiguous like size of memory, everything is contiguous, and you only have the address of the first element. What I'm saying right now is it might seem very theoretical information, but in fact, it's very important that can differentiate a good programmer that takes into account the memory behavior, the compiler, the hardware you have, versus someone else that just write. You will not find this information in details in, for example, like programming forums in like fast ones, right? They will only tell you how to use arrays and how to define them. But understanding this is very important. For example, if you go to an embedded system course or computer organization course in the computer engineering curriculum, you will start using some embedded systems, right? And those embedded systems has very limited memories. So now you would start having these limitations in a real example, like in a microcontroller, for example, and you need to care about these, right? Good. So now I'll stop because this might be an advanced thing. I'll see questions you have. Oh, is there lagging in? Is the lagging still persists or it's fine now? Okay, good. Thanks. So are we talking about, so I guess there was a question here that I forgot what was that? Are we talking about memory overflow? This is a kind of an advanced topic that we don't talk about right now, but it's connected, yes. But this is kind of an advanced topic that's not good to discuss during this lecture. But if you have further questions with regard to this, maybe you come to the office hours. Okay, good. So given that now we understand the basis of an array, let's see how things happen in C, right? So array in C, you have to have the same type. So because you define an array of ints, for example, you cannot have a mix of types. They are contiguous in memory, and you define your array size statically at the beginning when you declare it, right? Array name and subscript or index represent the position of an element in the array. So what does it mean? For example, when I say AI, that means I'm trying to access element I in the array. So if this is A in the memory, right? The index I is telling us that this is element AI, right? This is how you access certain element in an array. And you start from 0. Because, for example, in MATLAB, you start from 1. So the languages like differ in this, but in C, the array index starts from 0. Similar to anything in C, before array is just a variable. So before using an array, you have to declare it, and we will see now how to declare that. Okay. So let's say, for example, I want to define an array that holds 10 integers. So what I do is, first of all, I define the type of the array. So here it's int. It can be double, float, character, any other things. And then the name of the array itself. This is a variable. You can call it anything as far as it's a legal name. And then the size of the array. Here it holds 10 integers, so it's from 0 to 9. This is the size of the array. Good. If I want to define something that is like 100 values and then double, then I do exactly the same thing. The type is double. I use whatever, as I said, whatever legal name I can define, and then the number of elements I have, right? Okay, so now after defining an array, assume you want to access a certain element and assign it certain value. For example, you want to assign value 34 to the element stored at index 4. So you just write the array name, what element you want to access, and then what value it would have. So if you look into my array, this is element 0, 1, 2, 0, 1, 2, 3, and this is 4. You want to, what this is doing, it just writes 34 to this place in memory. This is my array, right? So if you want to read it, you do the other way around. You say, for example, int, this is double, so you say double x equal my array 4, right? And we'll see right now how to use it. Good, so before jumping into how to do our example using arrays, let me see if you guys have questions. So could double be elements input by the user? Yes, and we will see now that we will take the 15 floating point numbers from the user. What about unsigned values? So signed or unsigned, this is with regard to the type that you are defining the array in, right? Int in general, double as well, take both positive and negative numbers. So they are signed by default. But you can define an unsigned variable, and we will see right now when we talk about advanced types, why you might need, for example, to define something as unsigned, right? But for now, you can enter things with sign as well, because you didn't decide. So let's see. I guess maybe the best way of doing this is but before jumping into the OpenGDB, let's think about what algorithm what should be the steps. Like let's take a few seconds to decide of how to write this program. Because if you remember lecture 0, what I told you is before writing any code, you need to come up with somehow an algorithm or data structure of how your program should look like, right? Like what steps you need to write. Because before doing that, jumping directly into the code, it will be a mess. You need to organize your mind, right? So what I want to do, I want to read 15 things from the user, but now I want to store them in an array because I want to reverse their order. So I need to keep track of them. So the first thing you need to do is to define, okay, so I guess just doing that. You need to define your array, and it has to be floating point, and it should be holding 15 elements, right? This is the first step. Then, through a loop, you want to ask the user to input something, to input a floating point number, and this loop should be 15 iterations, right? Because you want to read 15 times. So you ask it to input a floating point value, store this value in the array. So let me call this fp array. So you store this value in fp array. And then after you are done with your 15 things, you want to reverse them, right? Because you have them assume I have only 3 values for now, just to give you an example. And this is a skill, in fact, that you need in the lab or in the exam or any project. If you feel that the problem size is big and you don't have a clear mind of an example, just simplify the problem, because the algorithm would work exactly the same for 15 values or 3 values or 300 values, right? So simplify it, assume only have 3 values. So assume the user inputted something like 1.5, 3, and then 2.2. What you want to do, and because you store things in this order, you want to reverse it, right? So you want to start printing things, but not from element 0 to 2. On the other hand, you want to do this from element 2 to 0. So you need another loop here, but it's in reversed order, right? So it should start from 15 or 14 to 0, right? And then you print your array in this reversed order. This is just what you want to do. What do we call this? This is something that is like a pseudocode or an algorithm or something that doesn't matter what is the name, but it's something that you should always do in any problem before writing the code. Why? Because it abstracts the steps you need to do, right? So you need to understand, especially if the problem is a little bit complex, it will help you organize your mind. Good. So after doing that, let's see how to implement this in C. Elements that have not been assigned values will be 0 by default. We'll come into this. Do arrays value need to be initialized or defining this? The size is enough. Okay, that's also an excellent question. Okay, yeah, maybe I should just address this question now because it's a general one. So the question is saying, Benjamin, and thank you for this question because it's a good one. Do array values need to be initialized? Last lecture we said it's a good programming practice that defining any variable in C, when you declare it, also initialize it to 0 or any value you want, because you don't want this to hold any garbage value from the memory. What about arrays? Arrays are good in the sense that they are initialized by default to 0, right? So you don't need to initialize arrays if you don't want to, right? But I would still say it's a good programming practice if you know, for example, you want all the values to be 0, just initialize them to 0 or any other value you want, right? But as a rule, arrays are initialized to 0 by default in C. Good. Okay, so let me then jump into online GDB. And share with you. Okay, given that we have our algorithm, let's go through step by step on how to do that, right? So first of all, I want to define my array as floating point. So you can either define this as float or double. So what is the difference between float and double, right? This is the time to discuss this. A double is like a double floating point number, right? So in digital design, in your architecture, in your laptop or desktop, there are two different things. There are, first of all, double and float, both are for decimal values, like the thing that has a decimal floating point, right? Like 1.5, for example, they are not int. So, but both are different. Float, in general, are smaller variables than double. So double is a 64-bit, so it's double floating point. So it's 64-bit value register, right? And most of our modern machines are 64-bit registers by default, right? But previously, like for example, 5 years ago, most of machines were 32. So the float was the common one. Float are only 32-bit decimal values. So generally, double will be able to hold more values than the float. So if the double is 64-bit, it can hold up to the power 64 minus 1, right? And if, because it's signed, it should be plus or minus 2 to the power 63 minus 1, because both from the negative and positive side. This is kind of a bit detail that you might need to care about, but what you can do, you want to understand is double takes more place in memory than a float. But also it can hold in larger values. So if you know that your variable here, the user can input anything, right? So just to as a safeguard, I define this as a double. But if you know, for example, in your program that you only need small floating point values that, for example, has only 3 decimal places or digits, or 4 or 5, then float is enough, right? So double, and then I want to define my array. I will call this array, and then we said it's 15 values, right? And then what do I want to do? I want to have a loop and then ask the user each time to input something. So I would say for int, something that is better to do in all C's is to define your iteration before this. You don't need to do this. You can do this here. And then I less than 15 and I plus plus, right? Good. And then each time you ask the user to input something. So printf, please input a floating point value. And then that's it, new line. And then what do I need afterwards to read from the screen? Scanf, right? So you do f scanf. Sorry, f is from the file, sorry, scanf. And then I want to read something that is double. Now we're not using the specifier as d, right? We want something that has a decimal point. So in this case, you can use f, right? Because it's floating point number. And then you read this into, where should I read this? I want to place this value somewhere, right? Right? So where can I place that? In the array, exactly. In the array at I, right? So I would say this is array I, right? One question that you will all have is why I didn't do that. Remember we said scanf want to modify the variable, then you need to pass it by its address, what we call pass by reference, right? But in arrays, you really don't need to do that. Why? Because arrays are passed by reference by default. So what I mean is, if you pass an array to, but here we're only passing a floating point value, so it might be even worse doing it just as a safeguard. But as we will see on how to pass arrays to functions in coming lecture, arrays, because they are contiguous places in memory, they are passed by reference by default. What I mean by passed by reference is they are modified inside the function itself, right? But if it's a bit confusing, we will come into next lecture about this in detail on how to deal between functions and arrays. But here you use it if you feel you would be consistent from previous lectures. So I'm reading here the value, placing it in first in element 0 in the array, then element 1, and then I do this 15 times, right? By reaching to this point here, I have finished the step that is defining the array, reading the 15 values from the user. What would be the next step in our algorithm? If you look it up, it would be, I want now to reverse their order, want to display them in a reverse order. And we said for this, we need another loop that starts from the end to reverse the order, right? So I would start from 14. And then I would say I larger than or equal to 0. And then I subtracting. And then I will explain what is that, because also a good point of the example of how to a little bit play around with the for loop conditions, right? And then now I want to display it to the user in the reverse order. So I would say print f, and then here it's f space, and then this should be array of I. Good. Okay, so what we have done here, I'm starting from element 14. Why? Because we have 15 elements in our array, and we said the first entry in C in the array is 0. So 15 elements are from 0 to 14. So the last element is 14. And then I keep subtracting. Okay, if you are confused with this, let's write this in this way. And then let's write this in this way, because we didn't discuss this plus, plus, minus, minus yet. So we are subtracting 1 because we want to move 14, 13, 12, 11 up to 0, right? Here I'm stopping at like larger than or equal to 0 because I want to include the 0 in my calculation or my iterations. But here it's only less than 15, not equal to 15, because 15 is not an index and a valid index to the array. Again, we said it's from 0 to 14. So 15 is outside. So I stop at less than 15. Good. Does this make sense? Yeah. So let's try this for a smaller number of elements. Let's say, I don't know, like 5, for example, and see if things work. And by doing this, here we should say 4, and this should be 5, right? Let's see if this works. Oh, so always forget that. Okay, I just stopped. Okay, so here it says that f is expecting a float, but it's double. And we'll see now different specifiers for float versus double, but the main thing is we will not be enter something that is very large enough. So that's that warning we wouldn't face right now. So let's input something. Let's input 1.3, then enter another one, 4.5, and enter, then I don't know, 8.3. It asks me for 4 times because I have, okay, 1, 2, 3, 4, so let's say 6, and then last one with 5. Oh, so it just displays zeros, right? So let's see what happened. That's a good thing to debug stuff. So let's see what happened. What I do here is I start from 4, and as far as larger than 0, and I print the array I. That's very interesting. So let me say if I only send that. What would be the problem? 1, 2, 3, 4, 5. Still perfect. So let's see if some of you already got some ideas. It depends on what you need. If you need a carried decimal, it's double. Because you have return 0, no, because here this is with regard to the printf thing. Do you use double arrays because we count them 2 times? Size of array gives the number of bytes of the array. Could you do the print within the first loop? Yeah, that okay, Hannah, that's an excellent question, Hannah, and we didn't discuss this yet. This is a bit of optimization that we can do. But first of all, let's focus together on how to debug this, why we are printing zeros, right? So maybe I would just say nj equal 4, just to make sure we are, sorry, here. Then use a different one. And let's see if something that is J. Interesting. So, okay, something I can do is I try to print this here to see what's going on. Is just here, I run 1. Okay, here we see. So let's see that if I do that. Okay, sorry. Do that, then I do. Oh, it didn't work. Just want to send that.
Look in the chat. I think someone knows why it's wrong.
Okay, thank you. So let's see.
Hi. So I think the problem here is that at your scanf, it should be mod LF since you are scanning the value into the float. So
Yeah,
I believe this is F, right? So it would just input string instead of float or something like that.
Okay, thank you, Aaron. So this might be a problem of this compiler. So let me reiterate of what Aaron is saying, and we try it and we see. So the point is this warning we got at the beginning because F is only for float, right? And I told you that double is double floating point. Ideally, this should work fine. For example, if you try it in GCC, it should work. And the reason is you are kind of casting from a float type to a double type. So this casting is done by default, so it shouldn't be any issue. But given that this is an online compiler, it might have a limited support. So once you have a warning, it might start acting weird. So maybe if I don't already try this in online GDB, so what he's suggesting is, okay, let's get rid of this warning anyway. And then we do this by trying the LF, because LF is long float, which is effectively the double that takes 64 bits. And this might end up solving the problem. But something for you to understand, okay, so we'll try to see if this works. But the general lesson is, even if this works here, you should know that some compilers are different from other compilers on how strict they are. What I mean is, some compilers will do the casting by default, right? Because they have, or for example, the C toolchain. In Lab 0, you installed Oriole toolchain, right? Including the C, either in Windows or Mac. The C toolchain itself, including the compiler, would have all the libraries that are needed for the things that are going in the background. One of the things that go in the background is you can in fact assign a float value to a double value without any problem. And we will come into this in coming lectures in what we call casting, because float and double both are representing the same thing, but in a different length, right? The point is, again, this is an online compiler, so it might have to be able to run fast and to accommodate many users. It might have some limitation of, for example, if there is a warning, just don't run the program correctly because you have this limited support, right? This might be a reason for that. So let's start. Okay, so now this works. Okay, so that's the reason then. So thanks a lot, Aaron, for that. But again, you need to like differentiate between what is really syntaxically or wrong thing in the language and what might be a compiler limitation. This is the first lesson, right? The second lesson is warnings. Don't just ignore them by default, right? Because a warning, even in Eclipse, it will give you a warning if something that can work correctly, but the compiler has an issue with. So it might act weird under certain scenarios. And this is one of the things that we face right now, right? So always read warnings in a bit of a detail and try to address them, right? Why did Brent, well, okay, because here I see that question. So going back to the basics, I'm printing, what I was doing to debug is I'm also printing the array here, right? So you only want to print it once. So if we run the final version of what we want, it's 1, 2, 3, 4, 5, and then it only prints once, right? Because I just removed the debugging message from here. Good. So let's see other questions. Okay, so what else? So there was this very interesting, let's play around with this code, right? To see different versions and how to optimize. One excellent question was that, can I really get rid of this loop here to write a more efficient code? And the general observation about this question is, you can write the same program using multiple ways, similar to what we have done in the last lecture. Some of them are more optimized than the other. And in labs, you will be asked to write an optimized code. So let's think, if I get rid of that, one problem is I want to print things in the reverse order, right? So the suggestion that Hannah said is, maybe I can get rid of this and then do the printf here starting from the end, right? Oh, but this is not going to work. Why? Because when you read the first element, you didn't read yet the last element, in fact, all the subsequent elements, so it will have 0 by default, right? So you need to wait until you read everything, right? Does this make sense? So that such optimization is not possible, right? Does this make sense? Yeah, it might be possible by some hacks, but just the proposed solution doesn't work. Scan. Okay, so are we good? Can you create another pointer? You guys use advanced names. So I guess what you mean is another index to the array. It's not the problem, because this is what Hannah suggests, is saying I can start from the end because I know I have 5 elements. So let me go back to the slides and explain this to you. Okay, so basically the point is, you have your array like this. Assume I only have 3 elements for now. I read them one by one. So my I at the beginning is here. So what Hannah suggested, or the last kind of comment suggests is I can have another index here that is j, which is basically here is 3 minus I, or generally it's in fact should be 3 minus I minus 1, because you have 0 to the size minus 1. But the main message is you want to start from the end, right? The problem is in the iteration that is doing I right now, for example, think of the first iteration, which is 0, j will be at the end, so it doesn't have the value yet because you didn't read it. So you cannot start reversing until you read all the values, right? This makes sense? Good. Okay. So let's given that we are done with this kind of basic example, let's look for something else that we can also have different variants, right? So what I want to do here is to ask the user to input a sequence of 20 integers, store them in an array, but now not just print something in reverse order. I want to include conditions as well. So I want to check if the sequence is sorted in a non-decreasing order, right? Let's think again of the algorithm or what we want to do, right? First of all, I want to check if something is sorted, which means I cannot just iterate through the elements without storing them. So again, I need an array, right? So what you want to do is you want to define your int array of 20 elements, and then you want to have some sort of a loop that goes from 0 to 19, and then read from user, right? Then this first step, second step, and then after I read everything from the user for the 20 elements, I want to check one by one whether they are sorted, right? How to check if something is sorted? You can simply start from the first element in a non-decreasing order. Then you look into, for example, element 0, compare this with element 1. If it is smaller, that means you just broke your condition. So it's not sorted. You have already decided, right? But if it's larger, then now you satisfy the condition. So you move to 1 and compare with 2, then 2 compare with 3, etc., etc. So as an example, not for 20 elements, but again, let's look into, I don't know, 4 elements. Assume I have an array that is like 4, 3, 1, 0. And this starting from the first element is this. So what I can do is I have an index here that starts from the first element. Compare this with the second one. Is it larger? Yes. So you satisfy the condition. Great. So you then move to the second element. So you move this to be here and compare with that. Is it satisfying the condition? Yes. So you move here and compare with that, right? It's satisfying the condition and you are done. Great. So that's sorted. Another example would be if I have something like that. It's like 4, 3, 5, 1. So I start from the beginning. Compare this with a subsequent element. Is it larger? Yes. You satisfy the condition. So you advance your iteration. Compare this with this. Is it larger? No. So you broke your condition. Then you are done, and that's not sorted, right? So this is how you can do your check for sorting. Does this make sense? So if you guys have a question with regard to this algorithm before we go ahead and implement it, so let me look into the chat. Shouldn't this be increasing order? Yeah, I was doing, okay, so it's yeah, that's perfect. I just reversed it. So you are correct. But in fact, non-decreasing doesn't mean increasing. Okay, maybe it's a good point to discuss this algorithmic point. So what I was doing here, in fact, I was doing in a non-increasing order, right? Right? But what we want to do is a non-decreasing order. So what is a non-decreasing order? Is it increasing? Is this equivalent to increasing? No, right? Why? Because this array, let's say the same one that we had for the other order, this one is, okay, so in fact, I want the correct one, which is this one. This one is it's violating both, so I should just do this. Let's say 1, 2, 3, 4. This one is an increasing order, yes, so it's increasing. And it's also in a non-decreasing order, right? Because every element is, in fact, larger than the one that is before it, right? But what about this one? One, one, three, four. This one is non-decreasing, right? Because you never decrease, so it's non-decreasing. But is it increasing order? No. Because you don't always increase. So if you have equality, so effectively increasing is more restrictive than non-decreasing. So because non-decreasing would include the equalities as well, right? Okay, so let's do this in a non-decreasing order as the question is saying. So let me share my GDB. Okay, how many elements? You said 20 elements, I guess, right? And it's an int. So here I do this as an int, 20 elements. And then I want to read from the user for 20. That's now fine. Input an integer value. And then I read this as integer now. And then this should be array I, that's okay. Now, after I define my array, I read the 20 elements. I want the last step, which is start checking the condition that I have, right? Which is non-decreasing. I kind of forgot, but let's say it's non-decreasing order. So what I want to do, I want to go ahead with all the elements one by one. So starting from 0 to 20. And then I want to check if the current element is, we said, non-decreasing, right? So you want them, let me just make sure I read it correctly. I don't want to confuse you more. Yes, so it's non-decreasing order. So if this element is larger than the element afterwards, right, then it is not non-decreasing. Else it is, right? So effectively, if the current element is larger than the one afterwards, that means now you are in a decreasing order. You would bring some message to the user saying that, oh, it's not sorted in the condition you have. Otherwise, it should still be okay, right? So let's think of this logic. The problem is, okay, if I broke my condition once, then I'm already done. I know that it's not non-decreasing order. The problem is I cannot say here if array 0 is larger than array 1, is less than or equal to array 1, it's the array is sorted, because you still need to keep track of the other elements, right? If we go back here, oh, why did I stop sharing? So let's take some examples to make sure it makes sense. I have 1, 2, 4, then 2 again, right? And think of the logic that we had so far. I start from here, compare this with this. It's less. So if I just printed that the array is sorted with the first 2 elements, I didn't finish my condition yet, then that's wrong, right? But on the same time, you want to keep track if things in the right condition, right? So you might want to have what we call a flag, right? So what we mean by flag is just a variable that holds the status over different iterations. So I would say int flag equal 0. And this flag would be, if it's non-decreasing order, so your flag here would remain 0. Otherwise, your flag is 1, right? So why I'm doing this? This logic is important, right? So the logic is what we are after in this example. So try to make sure you understand the logic. I want to keep track of a certain status over the whole array, right? And to be able to do this, I cannot just print a message. I want to keep this forward. So I want to know what is the value of the flag at the end that is taking into account all the comparisons that I'm doing, right? So here what I'm saying is that this shouldn't be I0 anymore. This should be J and J plus 1 because we want to generalize, right? But then if J is larger than J plus 1, then flag is 0. And here I'm just interpreting the flag as if 0, it is not sorted, and if 1, it is sorted, right? So each time I'm setting this flag, if the value, if the condition is not satisfied of the sorting, I set the flag to be 0. Otherwise, my flag is 1. At the end, I want to check the value of my flag, right? There is still one problem with that. The code will not work. What is that? Because you update the flag each time. For example, if the condition is broke in the first 2 elements and the flag is 0, but it's not broke afterwards, the flag is 1. Here you will find the flag is 1, although in fact you had a break in your condition, right? This makes sense, right? So something you can do is you say, I in fact set the flag to be 1 at the beginning, but if the condition is broke at any time, I set the flag to be 0. Which means if you end up after this loop and your flag didn't change, so it's still 1, that means there was no single condition that it was violated across the whole array, right? So it might be confusing. So I want you to because this logic is used most of the time in programs. So let me just simplify. I was thinking with you rather than just giving you the correct solution. So what I wanted to do is I'm beginning my array, my flag as 1, which means I'm saying, okay, by default, it's satisfied, it's sorted. So this is a hypothesis that I have at the beginning. And then I check between every 2 elements. Once any 2 elements break the condition, the flag will be 0, right? So at the end, if the flag is still 1, then you can simply print F, it is sorted. And then else, what? Then else, you print F, it is not sorted, right? But this code has a problem, right? I know that some of you in the comments are suggesting things, but this code has a problem, right? I want someone to identify this problem. Exactly. So thank you, Hayu and Ahmad for that. So here we are going through the whole array from 0 to 19. The problem is if we are checking every 2 successive or subsequent elements, I want my pointer or index to stop at the one that is before the last one, not the last one, because you cannot compare the last one with something that is not part of the array. So you need to stop at 19 because the last condition should be comparing 18 because it's less than, so you compare 18 with 19, right? So the last and the one before the last are the last comparison you have, right? Good. So this is the logic, but I know some of you in the comments are suggesting different alternatives or maybe more optimized code. So let's look into what we can do with this code. One is saying, once your flag, so what do you need at the end from this program? So you want to check whether it's sorted or not, right? And you know, once you break the condition once, it will not be sorted at the end, even if it's sorted for all other elements, right? So there is no need to continue your loop to reach the end if you know, for example, the first 2 elements are not satisfying your condition, right? So here we introduce the break statement. And what does a break mean? A break means you will not continue doing subsequent iterations. Here I have 20 iterations from 0 to 19. But once one condition is broke, I don't need anything else because the flag is 0 by default, right? So I just break, which means I don't continue my comparisons in the subsequent elements. Why it's useful? Because it will save you some calculation time, right, on average. For example, if the first two elements are not satisfying your order condition or sorting condition, then why you bother checking others? You are done, right? This is one optimization we can do. What else we can do? Let me see your suggestions here. Then J would have to start at once. If he's missing a bunch of brackets, I guess he is referring to me. No, you don't. That's also a good question. Thank you. So what he's saying is maybe for F and else you need those bunch of brackets, right? So if it's a single statement, you don't need those brackets. But a good programming brackets, and I'm sorry for confusing you, you can do this if you wish. But the general rule is if it's just a single statement, the body of the F or the else is same, or the loop itself. If your block of code is single statement, you don't need those brackets, right? But if you are confused, both them, you don't lose anything. Thank you. So what else? Could have a while loop. Yes, you can. Yeah, that's also an alternative we can do is you can implement this using while. In fact, even in for here, without, you can get rid of the break by saying if j is less than 19 and flag is not 0. You can add this in loop, in for loop. So in the main syntax of this middle statement in the for definition is a condition. No one, this should be and. No one said that this should be a single condition. It can be a composed condition. It has two things. You check whether j is less than 19, but also you check if flag is not 0. And then in this case, you don't need the break statement. But this is not a very right way of doing, it's correct, but it's not the optimized way of doing a for loop, right? So maybe if you do this, you can do this with a while loop, right? And maybe this is something you can try offline as an application to this lecture or as like a very simple assignment that's not graded for you, is try to replace this with the for loop, right? Okay, so I guess we are past the time, but we are done with the example we have. Let me see if there are other questions. So others, please feel free to leave if you wish. We are done. I just check if others have questions for a few minutes, and then I will jump into the office hours Zoom link. Thanks, everyone. Can we print info and return right after the flag is 0? That's also, okay, I like that one. So what he's saying, in fact, I don't need to do the break and then print stuff here. What I can do is, if I know flag is 0, I can just say it's not sorted, and then return. You just do this, right? And because you just do return 0, so you finish your program, and you don't need this here. And if you wait and you didn't return until the end, then you can just print it sorted. Because if you reach this point here, that means you never return it, which means flag is always 1 until you reach the end. This is also another way of writing this program, right? So thanks for the one who suggested that. Wouldn't the and flag node 0 need to be in the if statement? No, adding it in the for loop. So Matthew, I guess this is your question. So adding this in the for loop would say in the subsequent iterations, don't do the remaining iterations. So you don't want to jump into the for loop even if the flag was just once, 0, right? Can you run the program? Yeah, let me run it for sure. Okay, we're missing something. Expected declaration statement, then 7337. We are missing something here. So this is for this F. Yeah, because I added multiple statements instead of one. Okay, so it should be this one. Okay, input an integer value. Oh, but that's going to be 20, right? So let's stop and make this 5. Okay, then 1. So 1, 2, 3, 4, 5. Then the loop is until 20. That's bad. Okay, that's 5, and then that should be 4. Then 1, 2, 3, 4, 5. It's sorted because I entered 1 to 5. So let's run something that is not sorted. I would say 4, 5, 2, 3, 1. It is not sorted. Okay. Why use and instead of semi? So forget about the and for now. We will come into these logical expressions if you don't remember them from Python. So it was just an example. So and means it's logical and. So you check 2 conditions, not a single one, right? Thanks. Does the GitHub username have to be the same as Mac ID? Har Sahib, like this is your question. So what you have to do is your GitHub account has to be created using your MacMaster email. Otherwise, your lab will not be able to get marked with the automation we have. So your GitHub account has to be using your MacMaster email. This is the condition we have. If you, I know in GitHub you can change your username, but as far as your, I wouldn't really in fact recommend, but if you want, that's okay. As far as your email that you use for your GitHub is your MacMaster. Thanks everyone. Okay, because I guess you might have, let me see if you guys have any other questions that I didn't address. Has no built-in bool type for the flag. Oh, that was a good question. That Cass was replying to, but I don't know whose question was that. So the question was that the flag can be a Boolean type, not int, because it's either 0 or 1, which means true or false. You are correct. But C doesn't have Boolean built-in type, right? So Booleans are interpreted by int. Anything that has a 0 value is false. Any other non-zero value is true, right? And this is how we do it in C. Okay, thanks everyone. And then I will be in office hours if you have any questions with regard to lectures or labs. Thank you.